Hello 6-7s, this is Mrs. Marcy here. So this video is to accompany the grade 7 math work scheduled for Tuesday, April 14th. 6s, you're welcome to try and give this a go, but it is a little bit trickier and it does involve some long division along the way. So there's this video, and then later in the sets of slides there is a math antics video, and he's really good at showing you the division part and explaining it through, but I'm going to explain it here. I'm going to go slide by slide so that if you get stuck, you can look back at this video and figure out what I'm trying to get you to do for each of these slides. So on slide 2, it just is telling you that there's my video, which you're now watching, and a math antics video, which is really going to be helpful a little bit later. So there are really two kinds of decimals, and up to this point, we have pretty much only dealt with the one kind of decimal, and we call it a terminating decimal. If we look at the fraction 1/4, 1/4, 1/4, I know and you know that that has a decimal equivalent of 0.25. Ooh, I have a very squeaky marker. And that is it. That is the end of the decimal. There are no new numbers added onto there. I can add a 0, we do know that I can add a 0 at the end of my sets of numbers, and it doesn't affect the value of it in any way. But when I divide out 1 divided by 4, I get 0.25. It is a terminating decimal. If I look at the fraction 2/5, I know, and you know, that it has a decimal equivalent of 0.40. That's it. That is the end of the decimal. It does not continue on. Right? Again, if we do one more example, if I take the good old fraction of 1/2, I have the decimal of 0.5. Now again, I could add some zeros onto there, but it still is the value of it is the same. And these are called terminating decimals. They have an end. Terminating is Latin, terminate is Latin for to end or to stop. And so these are terminating decimals. They only go so far. The next slide, though, talks about a new kind of decimal, or something you may have seen before but didn't know what it was called. And it's called a repeating decimal. So if I look at the decimal 0.32, 32, 32, 32, I can assume a couple of things. Mostly that this pattern is going to continue forever. If I had to predict what the next number is going to be, I'm going to guess with accuracy that it's going to be a 3 followed by a 2. That this pattern repeats over and over again. So we call this a repeating decimal. It doesn't end, it goes on forever. Sometimes decimals that are repeating decimals can be the same number repeated over and over again. And again, I can predict with accuracy that the next number in that pattern is going to be a 1. Often, however, my repeating decimals have a larger repeat. So for example, this decimal has 3 numbers that repeat over and over again. 0.789, 789, 789. And as long as there are no new numbers included in there, then we can assume that that is in fact a repeating decimal. And they will repeat forever. The next slide wants you to look at some of the examples of decimals and determine whether or not they are repeating decimals or terminating decimals. If they're repeating decimals, change their color. And you have to be pretty careful because some of them look a bit trickier. There is a big difference between 0.22 and 0.22222. This one, the first one, we're going to assume stops there, 0.22. If the decimal provides us many decimal places, all of the same number, then we can assume that it's going to repeat. This one, because it's only provided us 2, we cannot actually assume that the next is now going to be a 2. We will assume that it is 0.22 and then it stops. All right, next screen is our math antics guy. So watch the video and you will discover that he's really good at describing how to divide fractions. Okay, so let's look at one of the examples. We wanted to find the decimal equivalent of 1/5. So we need to do some long division. So when I say this as a division statement, it's 1 divided by 5. I'm going to repeat that. It is 1 divided by 5. So I need to set up my equation as a 1 divided by 5. All right, let me do that again just so you can see it. When I'm setting up my equation, I need to set it up as a 1 divided by 5. And it's very, very important where the numbers go. The numerator goes inside the divided sign, and the denominator comes on the outside of the divided by sign. Okay? We already know, because we're brilliant in grade 6-7, that 1/5 equals 0.2. But we're going to prove that using some long division. So the first thing I need to do is how many times does 5 go into 1? It doesn't, right? 5 cannot go into 1 equally. So up here, I'm actually going to put a 0 right above here. Now this 1 really has a value of 1.0. So I'm going to actually now write the 1.0. And then I'm going to take this decimal place that I put down here, and I'm going to put it up there. Now I'm going to look and say, pretend the decimal place isn't there, even though it really is. And I'm going to look at this now as the number of 10. So now my question becomes, how many times can 5 go into 10? Well, if I count using the multiplication chart, it's 5, 10. It goes in 2 times. So I'm going to put a 2 up here because it goes in 2 times. And then I'm going to multiply. 5 times 2 is 10. I'm going to bring it down here, and I'm going to subtract. And again, we're kind of ignoring that decimal place for a moment, and we're going to do 10 take away 10 is 0. When we get to 0 down at the bottom here, we know that we have a terminating decimal, number 1, and number 2, we know that the equation has stopped. So we found out that 1 divided by 2, or 1/5, equals 0.2, and we did it using long division. All right, so let's do another example. There's 4 more on paper that, there are 4 more on the slide that asks you to do them on paper. If you want to submit your paperwork as well, take a picture of it and attach it to the slides, that would be great. Add another slide in, import it as a picture. You don't have to, as long as you understand what's going on here. So the next question is 4 divided by 10. Now again, for our samples, we already know, because we're smart, grade 6-7s, that 4/10 really has a decimal equivalent of 0.4. But we want to prove this using long division. So we're going to set up the equation of 4 divided by 10. And again, notice that the numerator goes inside the dividing sign, and the denominator comes on the outside of the dividing line. So then I'm going to start my questioning. How many times can 10 go into 4? Well, it doesn't. So we're going to put a 0 up here. And we know that 4 really means 4.0. So I'm going to add my decimal and my 0. And then so I don't forget, I'm going to put my decimal right up here at the top. Now I'm going to look at this as the number 40. So then I can ask myself, how many times does 10 go into 40? And if I think about it, it goes 10, 20, 30, 40. It goes 4 times. So I'm going to put a 4 up here. I'm going to multiply these two numbers, 10 times 4, and I'm going to get 40, which goes down here. I subtract, and 40 take away 40 is 0. So I know that I'm at the end of my question because I've hit a 0. And I know that it's a terminating decimal because that's as far as it goes. There's no more work to be done. And I just proved that 4/10 equals 0.4, just with long division. Okay. There's one more example on the page to try that's a little bit trickier, but it follows exactly the same pattern. Okay, sometimes we don't get a remainder of 0 right away, so we need to go a little bit further. So let's take the example of 1/8. We want to figure out what the decimal equivalent is of 1/8. Now, grade 6, 7s, you are not expected to know that right off the top of your head. That is not one that I suggest you memorize. So this would be a good time for you to use long division to figure out what is 1 divided by 8. So let's set up our question. And I always say it as I write it. 1 divided by 8. The numerator goes inside the dividing sign. The denominator goes on the outside of the dividing sign. So now I start asking my questions. How many times can 8 go into 1? It cannot. So up goes my 0. And then we know that 1 really means 1.0. So I'm going to include that now in my question. And so I don't forget, I'm going to put my decimal right above where it is in my answer. Now I'm going to look at this and say, how many times can 8 go into 10? Well, it can go in 1 time. So I'm going to put a 1 up there. 8 times 1 is 8, and I'm going to subtract. 10 take away 8 is 2. I haven't hit a 0 yet, so I need to keep going. So I can go back up to here. I put another 0 up there. And then what I was taught when I was your age is I put a little X down underneath that 0. And then I put the 0 down here. And that little X just tells me that I've used that 0 and it's now the 1 down at the bottom. Because sometimes our question gets really long and we don't want to forget what 0 we've used. So now I'm going to ask myself, how many times does 8 go into 20? And I can see it as 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. That's too big, so it goes in 2 times. So 8 times 2 is 16. Put the 16 down here. And subtract. And 20 take away 16 is 4. I'm still not at 0, so I need to keep going. So I go back up to my question. I put a 0, put a little X under it, and I bring my 0 down here. Sometimes I need to extend my division change. All right, now I am going to ask myself the question, how many times does 8 go into 40? Again, I'm also thinking 8 times what makes 40? So 8 times 5 makes 40. So I'm going to put 40 down here. I'm going to subtract, and I get to 0. So finally, I get to an answer of 0, way down here at the bottom. So now, if I look up at the top here, we have created a terminating decimal that's just a little bit longer than 1 or 2 decimal places. It has 3. And we have now proven that 1/8 has a decimal equivalent of 0.125. Pretty cool if you ask me. Now, I could have used a calculator and done top number divided by bottom number into the calculator, and I would have gotten 0.125. But this explains the how, which is really important for a lot of people. Okay, there's another question on that slide that you can do on your own. And let's try this one. 1 divided by 3. I want to know what the decimal equivalent is for 1 divided by 3. Now this is one that I suggested you memorize, but let's look at it mathematically and see what happens to get it. So let's set up our question. 1 divided by 3. These questions should be becoming quite standard to you. How many times can 3 go into 1? It cannot. So I'm going to put a 0 up here. I'm going to put a decimal 0 and a 0 there. I'm going to put a decimal up on my answer so I don't forget. Now I'm going to look at this question and say, how many times does 3 go into 10? Or 3 times what is going to get me closest to 10? And I know that 3 times 3 is 9, which is as close as I'm going to get to 10. So I'm going to subtract. 10 take away 9 is 1. And as I said, you can add a 0 up here because we're not really finished because this is not yet a 0. I'm going to put a 0 up in my question, put an X there to say I've used it, and bring it down. And I get a 10 again. And I'm thinking, I already did 10. So I know that 3 times 3 makes 9, which is as close as I can get, and that's going to leave me with 1. And I'm going to do it again just to make sure I can see where this pattern's going. There's my 0 that I've added. There's my 0 that I've brought down. 3 times what is going to get me closest to 10? And we've done it before, so we're going to do it again. 3. 3 times 3 is 9. That leaves me with 1. And I could literally keep going all the way down, and I'm going to discover pretty quickly that this is in fact a repeating decimal. It is repeating because I'm going to constantly get 3s all the way across the top. So we've created a repeating decimal. So my answer for what is 1/3 equal to, it is 0.33. And because that 3 repeats over and over again, I'm going to call that a repeating decimal. Okay. We don't always want to write 0.333333 every time we need to write what 1/3 is. That would take us a really long time, and then the question becomes, where do you stop? So if I needed to know what the decimal equivalent is to 1/3, at what point do I stop that? So I use something called bar notation. And bar notation literally puts a bar or a line over the repeating numbers. So that way I know that this 3 is the number that repeats over and over and over again. Okay? So, if it's the next couple of slides are asking you to write out each decimal to 8 decimal places. I've given you the space, so you can just put your cursor sort of in the middle of that line and then add your decimals in. So the first question is 0.3. So that was our previous example. So we know that the bar is above the 3, and that's the first number. So it is going to be repeating like this. And it can go on forever. Or in this case, 8 decimal places. The next question says 0.003, and then the bar is over just the 3. So in this case, if I'm going to write the first 8 decimal places for this, I'm going to write 0.003 because those zeros need to stay there to be represented. It's only the 3 that continues. So looking out for that bar is really important because that bar will tell you where you should be working on your repeating. So in the question 0.817, and it's over all 3 numbers, your decimal is going to look like this. It's 817 repeated. If the bar was only over the 7-1, and you needed to write this out into longer notation, then you still need to account for the 8. Then you're going to write the original 7-1. And since it is the 2 numbers that are repeating, that's what you're going to now write. So you need to be very careful and look and see, where is this bar notation? What numbers is it over top of? And that is what gets repeated. So there are 2 pages of quick questions on that one. And then it asks us to compare. So our example is 0.678, which is a terminating decimal. And we want to compare that, we want to compare that to 0.67. We want to see which one is bigger, okay? So the first thing we're going to do is we're going to write them, I'm just going to change that a little bit. We're going to write them underneath each other so that the tenths and the hundredths are all lined up, okay? Now this one is a repeating number. So if I was to continue this, I could continue it like that, okay? Now when I look at them, the 6, the tenths are the same, the hundredths are the same, but in this case, the 8 is bigger than this 6. So the 8 is going to make this one win. So 0.678 is actually bigger than 0.67 with bar notation. Does that make sense? This is my greater than, less than sign eating the bigger number. Okay? And so it asks you to go through a couple of those, just being very careful to notice where is the notation, where is that bar notation located, right? And there are 2 questions for that. And then it asks you to do 2 more sets of long division where your number is not a 1, where it's a 2 or a 4 instead. So for example, the question is asking you to find out what is the decimal equivalent of 2/9. So we're going to set up the question exactly the same way. 2 divided by 9. How many times does 9 go into 2? It does not. So it's going to still be a 0. I'm going to put my decimal and a 0 here, and I'm going to put my decimal here. So now I need to think, how many times does 9 go into 20? Or 9 times what gets me close to 20? And I know that 9 times 2 is 18, and I'm going to subtract them, and I'm going to get a 2. And because this isn't at a 0, I'm going to put another 0 here to continue, and I'm going to bring down the 20 here. So now I've got a question. How many times does 9 go into 20? Or 9 times what is going to get me close to 20? And we know it's a 2, because I can see a pattern developing, and I'm left with a remainder of 2. So just to make sure, I'm going to do it one more time, and I'm going to say 9 times 2 is 18, and that gets me 2. And so I can see that this is going to be a repeating decimal because the pattern is going to continue all the way through my long division. So the question is, what is the decimal equivalent of 2/9? And our answer is 0.2 repeat, because that's telling me that they're repeating only the 2. All right, I hope that helps. This one's a bit trickier, but if you watch the Math Antics Guy and you listen to my instructions on my examples, you should be successful. Chat with you later, grade 7s. Bye.